Okay, today lesson 23B. We've been working on two-dimensional shapes. A couple lessons ago we talked about how to find the circumference and area of circles, and then yesterday our focus was on irregular or composite shapes and finding the area or distance around those shapes. Today is our transition into three-dimensional figures, where we will spend about 3 or 4 days finding surface area and volume and things like that with three-dimensional figures. So our main focus today is on slicing three-dimensional figures and the two-dimensional figure that shows up when you're making that slice. So in order to do that, we have to spend a few minutes reviewing some stuff from earlier grades, like names of specific parts of two-dimensional shapes and three-dimensional shapes. Before we do that, we need to watch this little video here, and this is kind of a summary of the idea of slicing. All right, so let's put some terminology to some things from the past. And before we do that, the reason why we are slicing figures as it clearly states right here. This is one of our 7th grade standards, slicing three-dimensional figures in plane sections. Okay? So background knowledge from earlier grades. A plane is a flat surface, and when we are slicing these three-dimensional shapes, we are looking at the actual plane that results from that. And a plane, as it says up here, is a flat surface that extends forever in all directions. Typically, planes are made up of 3 lines or 3 points that are not on the same line. And we also need to talk a little bit about shapes and their names. We all know that a three-sided shape is called a triangle, and there are various types of triangles, but we're just going to stick with the name triangle for right now. Four-sided shapes, the main category of them is quadrilaterals, but there are specific ones like trapezoids, like rectangles, like parallelograms. I've always thought of a parallelogram as a rectangle that got squished sideways, because the same attributes are true about both, except what the angles that were 90-degree angles are no longer 90-degree angles. And the same thing is true with regards to a square. If you sit on the corner of a square and squish it sideways, that does not change the side lengths. And we typically call that shape a rhombus. So a rhombus is kind of like what's happening with the parallelogram when compared to a rectangle as opposed to a square. And 5-sided shapes are all in the category called pentagons. 6-sided shapes are all called hexagons. Now we could go above that. For example, a 7-sided shape is called a heptagon. 8 is an octagon. 9 is a nonagon. 10 is a decagon. Anybody know the name of a 12-sided shape? It's a dodecagon. But we can continue on, but these are the main ones. And these are the main ones that we want to focus on today when we do our little activity on the iPads. We're looking for these specific types of shapes. In addition to that, we're also concerned about a couple of shapes that don't have sides, like circles or a squished circle, which some of you might think is called an oval. It's really called an ellipse. So those are all the main shapes that we are concerned with today. The other thing that we will be throwing around, we'll be throwing around names of three-dimensional figures. Like when we're talking about a vertex, or plural for that is vertices, these are the corners of any three-dimensional shape. And then the edges are the line segments that make up that shape. And then the faces are the actual sides that make it up. So this pyramid is made up of a square. It's made up of also 4 triangles there. And it is that bottom, or the base, that is very important, and that leads us to something that's coming up, and that's how we name different three-dimensional shapes. So since the square is the base, we call that a square pyramid, and here is where you're supposed to be filling in things in your notes. Once again, the square is the base, and the base defines the name of that figure. So since the base is a square and this is a pyramid, this is called a square pyramid. And when we go to find volume of three-dimensional shapes, this is the part that's going to help you the most. thinking of the name of it will help you determine how you're going to go about trying to find the volume of the shape. Because not everything is nice and easy like a rectangular prism, which is what you would have done in the 6th grade. So here are some more shapes and their names. This is a square prism because it has a base that is a square and it is a prism. However, this is a triangular prism because the base is a triangle and it is a prism. This is a square pyramid because the base is a square and it is a pyramid. This, however, is not a square pyramid. It's a triangular pyramid because the base is a triangle. Then we have cylinders where the base is a circle. Sometimes that's called a right circular cylinder. We also have cones whose base is a circle. Sometimes a cone is also referred to as a right circular cone. And all of this, I know, is in your notes. So now, a cross section, and here's another spot in your notes where you're supposed to fill something out. A cross section is the two-dimensional shape that is exposed by making a straight cut through something. Might be a horizontal cut, might be a vertical cut, might be a diagonal cut. And in that video, all of those things were talked about. And today, when you're going to do the iPad activity here in a couple minutes, I don't want you to focus on just horizontal cut straight across or vertical cut straight up and down. I want you to try and go diagonally too, because what you're going to be doing is you're going to be trying to figure out all the different shapes that you can make. So here's a perfect example of a vertical cross-section cut through an apple. And the part that's exposed right there, that is the cross-section. Okay. So if I give you a cylinder and I cut it right there, anybody know the name of the shape that's in that cross-section there? And this is going to be one of those things where for some of you it's kind of hard to visualize what that is, and that's the purpose of today's activity. What is it, Jessica? It's a rectangle. And sometimes you need to kind of think of what it would look like straight on, and that was one of the things mentioned in that video. Straight on, it looks like that, and that is a rectangle. Here's another shape, a cylinder. This time I'm going to cut it that direction, horizontally instead of vertically. Now what's the cross-section look like, which is totally different, right? Would that be any ellipse? No, what would it be? Circle. Yeah, and you have to think about it straight on. I mean, if this is a glass of some sort of liquid like this, and you look at it from the top, there aren't very many glasses that you drink out of that are in the shape of an ellipse, right? I mean, if you look, that's clearly a circle. So sometimes we have to think about looking at that cross-section straight on. Okay? All right. In your notes, 1 through 4, go ahead and write the name of the shape of the cross-section. And then we'll compare with our shoulder partner. So this is one of those things where some people can just look and they know what the cross-section is. For some people, it's hard to visualize. And once again, the hard to visualize thing, that's the whole purpose of us using the iPad today through a little activity where you can sort of manipulate things to help you see the cross-section a little better. But number 1 should clearly be a rectangle. Number 2, if you look at it straight on, it should be a triangle, the cross-section. Number 3 should be a rectangle. Some of you might have thought it was a square, but it's at a little bit of a tilt there. Straight on vertical, that would be a square, but it's tilted slightly, so that makes it a rectangle. And that's one of the things you're going to see today as you start to shift the cross-section around vertically, horizontally, diagonally. The shape will change with just a little movement. And number 4 is by far the toughest one to see, but that is a triangle. So let me kind of show you what you're going to be doing today. Okay? So you're going to take the iPad, and there's 4 different shapes that you're going to start with. The first shape that you're going to start with in your notes is a cone. And so you're going to type in the website, which it should have it in your notes, and all of your screens will start like this. Okay? And right here, this section, that's where you can change the basic shape to start with. So you're supposed to start with the shape of a cone. And by default, it shows up like this. And so you're going to move the sliders around, and the shapes that you're looking for the shapes that we've talked about today. Okay? So for example, that's an ellipse. So you would write down the word ellipse. As I move this thing around, I can easily make a circle as well. But you want to move all the sliders around just to kind of see what that cross-section will look like. You can even change the radius of the original shape. So there are lots of things that you can do. And you're going to write down the names of all the shapes that you see with your shoulder partner. Now, the ones will take the iPad first. The twos will be writing down the shape names. And then you're going to flip. Okay? But just make sure that both of you have all the names of the shapes written down. So the ones will take number 1 shape. The twos will take number 2 shape as far as the iPad is manipulating. Then you'll switch back and forth. Now, what does the second one say to do? You start with a cone, then what's the second shape? A triangular pyramid? Okay, so here's what you'll do. You'll select pyramid, but by default, notice that the base is not a triangle, it's a pentagon. So down here on the slider, you can change the base to a different number of lateral faces. So right here we have a triangular pyramid. If you were asked to do something like that, then you could change it. Okay, so what I want to do is I want to go through and show you some of the probably the most common ones. When I show you these, it doesn't mean that these are the only cross sections. These are just the majority of the cross sections. So with the cone, you should have certainly seen a circle and an ellipse. And most of you also saw that if you went vertically, you could also get a triangle in there. And there's probably some other things you could find in there as well. Then the next shape you were supposed to do was a triangular pyramid. So some of the most common ones, obviously triangle, both directions. You should have also seen that you could make a trapezoid in there or other versions of a quadrilateral. Then you shifted to square pyramids, and then this is where you could start to get more shapes. You should have seen a square or a rectangle or both, a triangle, and then also a trapezoid, and probably a few other things in there that you could have found. But it was the last one where lots of things could happen. And you should have definitely seen a triangle, square, rectangle, trapezoid. Then we could start getting to shapes with more sides, like a pentagon or even like a hexagon. Some people in third period claim that they got a 7 and an 8-sided figure. I'm not convinced of that. That doesn't mean that they didn't, but that's the majority of them right there. So it was much easier for you to see these cross sections with this activity, and that's the reason why we did it. But this idea of a cross section, it basically is a prelude to several topics discussed in calculus, and that's usually the goal for students who are in honors classes at the junior high or middle school level is to get to calculus when you're in high school. But one topic is finding the volume of an object by slicing. And when we talk about the volume of a pyramid, I'm going to show you how the idea of the cross-section and utilizing calculus will prove the formula for the volume of a pyramid. But there's another one, and that's the principle titled Calavieri's principle. And that principle states that the volumes of two objects are equal if the areas of their corresponding cross-sections are in all cases equal. So here's a simple case of it, and then I'm going to show you a little demo, and then we're finished for today. Here I have a pile of quarters. It should be obvious to you that if I squish the pile of quarters sideways, that it should still have the same volume. The reason that they have the same volume is because the stack of quarters has the same height, and each quarter is actually the cross-section, and obviously all those quarters have the same area. So let me bring up a little demo here to further show that idea. And so for some reason it takes this, oh there we go. Okay, so we have three different shapes here. We have a triangular pyramid, we have a square pyramid, and then we have some funky pyramid there. The base of it is some weird shape, and you can see it in green there. But Cavalieri's principles tells us that they have to have the same volume, and the reason is because they all have the same height. They're all the same height. And in addition to that, the area of their cross sections is equal to each other. So the area of this cross section, that triangle, is 6.8, and GeoGebra is doing all the math for us. And the area of that quadrilateral there has an area of 6.8, and then the area of that green section has 6.8. So by Cavalieri's principle, they have to have the same volume, even though they're three totally different shapes. They're the same height, and their cross sections have the same area. Okay? All right, and that is it for today.